In this video, we will compute, step by step, the indefinite integral of arc cosine of x with respect to x, without skipping any steps. Our goal is to evaluate the integral of arc cosine of x, dx. Step 1. Choose integration by parts. The formula says the integral of u dv equals uv minus the integral of v du. We pick u to be arc cosine of x and dv to be dx. Then we differentiate u and integrate dv. The derivative of arc cosine of x is negative 1 over square root of 1 minus x squared. So du equals negative 1 over square root of 1 minus x squared, dx. And v is the integral of dx, which is x. Now substitute into the integration by parts formula the integral of arc cosine of x. Dx equals uv minus the integral of v du. That is x times arc cosine of x minus the integral of x times negative 1 over square root of 1 minus x squared, dx. The two negatives make a plus, giving x times arc cosine of x plus the integral of x over square root of 1 minus x squared, dx. Now, we focus on the remaining integral. We evaluate the integral of x over square root of 1 minus x squared, dx, by substitution. Let t equal 1 minus x squared. Then dt equals negative 2x dx. So x dx equals negative 1/2 dt. Replace in the integral. It becomes negative 1/2 times the integral of t to the power negative 1/2 dt. Integrate. Negative 1/2 times 2 times t to the 1/2 equals negative square root of t. Back substitute t equals 1 minus x squared to get negative square root of 1 minus x squared. Finally, assemble the result. The integral of arc cosine of x, dx equals x times arc cosine of x minus square root of 1 minus x squared plus the constant of integration. A brief note on the domain. For real values, arc cosine of x and the square root require x between negative 1 and 1. That completes our detailed, step-by-step solution.
Thanks for watching Myverse Maths. If this helped you, hit that like button, drop a comment, share it with your friends, and don't forget to subscribe for more quick maths tricks and proofs. See you in the next one.